Good afternoon, evening, or morning to everybody. Today's video is going to be about regression. And to kind of give an idea about regression, this might not be the textbook definition of regression. However, to have this definition out there, to understand what we need to do with a regression, I think is going to be a really, really good idea. Now, regression is a method to fit a function of some kind, whether it be quadratic, cubic, exponential, logarithmic, linear, anything like that, to a set of data, because we start to see a pattern in that data. One of our ultimate goals is to be able to extrapolate future information from data, or even past information from data based on what we have. So what we try to do is we try to fit a best fit function to the data that we have. It not necessarily is always perfect, because a lot of times in life not everything fits in a nice and orderly equation, but it usually is a pretty good representation of the data, and it gives us good information to move forward and especially to make decisions. So now, let's take a look at a situation. I am, say, a baseball player, and I am going to say, alright, here's the wall, and here's home plate. Let's say I hit the ball, and it does something like this. And it just nips the top of the wall, hits the top of the wall. The top of the wall is 15 feet tall. Let's say here, if we're talking about time versus height, and we say, alright, well at 0, 0, or at time 0, t equals 0, the height was 0. So we got the point 0, 0. So we're not going to take into account the fact that the batter might be 6 feet tall. Let's say after 1 second, the ball was 25 feet in the air. Let's say we had a maximum value up here. This was our maximum value. And let's go ahead and say that this maximum value was after 3 seconds, it was 125 feet in the air. And we can say at, let's say at 5 seconds, it cleared the fence at 15 feet, and then it hit the floor here, and it hit it at, let's say, 6 seconds, and its height was 0 feet. So I have 4 points. And what I want to do is I want to fit an equation to this. Now, since this is a projectile, the best fit, the best function that we can use is going to be a quadratic function. So if I understand that the real life process of a projectile can be modeled with a quadratic, that's a C, a quadratic function, we're going to use a quadratic regression. And remember, the regression is just finding the best function that's going to fit the data that we have. Now, there are other things that happen in this case. There's wind. There is all sorts of things that happen. So this might not be the most perfect quadratic equation, but it's pretty close to what we want it to be. So with these points, what I would suggest right off the bat is making a table of values, x, y. I have 0, 0, 125, 3, 125, 5, 15, and then 6, 0. And that's the information that we're going to need for a calculator. You can do this by hand. When I was in college, I had to do this stuff by hand. Absolute pain. So why don't we just kind of ignore that and say, all right, well, our calculator does a wonderful job of doing it. All right, so what we want to do is we want to hit the home key, which is right here, and I want to hit 1, create a new document. I do not want to save any other documents. This gets rid of everything. For regression, we are going to use lists and spreadsheets because lists and spreadsheets are where we input data. So we're going to use a list slash spreadsheet. Alright, so let's go down there. You can arrow down or you can hit 4. Either way, the top row up here are going to be labels. You can put X and Y if you want to. I'm going to put time. Whenever I have a chance to actually give a name, and I'm going to zoom in and out here so we might get a better picture. Whenever I have a chance to give a name to the variable, I'd much rather use a name. And this one would be height, so H-E-I-G-H-T. I always have to watch my spelling because I am a horrific speller. So I have time and height. So this is going to be the time for the baseballs. Now, we have our times. We have a 0, a 1, a 3, a 5, a 6. So I can go 1. Well, no, I don't really want to go 1. We'll go 0, 1, 3, 5, and 6. That's the easiest way to do it. Just dump them all in. And then we create the ordered pair. That's a 0. That's a 25. That's a 125. That's a 15. And that's a 0. Alright, so now let's see what we got. Once we're able to actually input all the data into the lists and spreadsheet, what we need now is the data graph. So what we're going to do in this case, let me move this over here. First thing we're going to do, besides write on our calculator, is we're going to go home again. So you can hit home or you can hit control plus page. Either way, I like to hit home. Makes more sense to me. And then 2, I need the data analysis page. And it's this 5th app that we have here. So I would go down all the way and go to data and statistics. So that's your data and statistics. I would hit enter. And now, as you can see, I have 5 points because I had 5 points that were on the trajectory of the baseball. So now, once we create that, we need to label our axes. So we need to go independent and dependent. So what I'll do is I will move the cursor down to here. It's very temperamental. And once you get down to click to add a variable, it says click or enter to add the variable. I'll just click, and it gives me the 2 variables that we defined. I need height or I need time. Time is independent, and probably 99 times out of 100 you're going to want time to be the x-axis. So now the dynamic software actually put this down here and said, alright, well, there's the hit at 0, 0. After 1 second, there it is. After 3 seconds, there it is. 5 and 6. Alright, so we're in business with that. But now I want to have not only time, but I want to have height. So I have to move the cursor over to the y-axis. Click on that. There's my height. And there is my trajectory. We started at 0, 0, then it was 1. After 1 second, it was 25 feet in the air. After 3 seconds, it was 125 feet in the air. After 5 seconds, it was 15 feet in the air. At 6 seconds, it was 0 feet in the air. So it doesn't look spectacular, but hey, if you've ever been to a baseball game, you've seen home runs hit in so many different ways. Now, to actually do the regression is just a couple keystrokes. So let me kind of move this over, move this up a little bit. Now, for the regression, one, hit menu. Or wait till the calculator turns off. Hit menu, and then in the menu, you want to go to analyze. And so that'll be my 4. Look through the list, and what we want is we want the regression. So we will tab down or hit the number 6 until we get to regression. When you have an arrow here, we can hit the right arrow, and it shows all the different types and even more of the different types of regression that we can have. So basically what this calculator is telling us is, depending on what our values, what our data looks like, we can fit different types of functions to it. We could fit a linear function to it if everything looked like it would be a straight line. We can fit median to median. Honestly, I'm not too sure about that. We can fit a quadratic. We can fit a cubic, a quartic. We can show a power function, an exponential, logarithmic, a sinusoidal, which is like a sine wave. What other ones are there? Let's see. Let's move down here. You have a couple logistic ones as well. But for us, we want the quadratic. So what we'll do is, all we have to do is, in step 4, go to show quadratic. And we hit BAM. And there is the best model that we can actually make based on this situation. So, does it fit every data point equally? No, but it tries its best to fit it and to make, if this was a perfect parabola, if this was a perfect moonshot that this batter hit, the function would be y is equal to negative 11.8707 x squared plus 70.56x point negative 9.80. And so this would give us kind of rough estimates. Now, what does this tell me? That maybe the data we had wasn't all that great, because there's a lot of what you want to see is you want to see these data points really, really close to the line. You don't want them far away. Sorry about that. This point is far away. This point, far away. This point, far away. These 2 points, pretty close on. So we would want them to be closest. Our calculator will give us the best we got. Sometimes the data you work with isn't great data. This might not have been great data. But what this does is it gives us a projected trajectory if this was a perfect shot from there. Now, there could have been a huge updraft which would have popped it up. It could have been hit into the wind, it got held up to the wind, and then all of a sudden the wind died and it fell. There are so many different other options that we'll deal with that we can't really worry about it. But as far as this graph, this is the function that the regression will give us. And it is the best possible function that we can use in that case. So that's what regression does. It gives you the best possible function based on the data that you give. If it's bad data, you're going to get a bad regression equation. If it's good data, you'll get a good regression equation. But your analyzation, remember, it's neither good nor bad. We don't assign a good idea or a bad idea. What we can say is that, all right, well, there's a reason why that ball might have made it up to 125 feet. There's a reason why that ball over here was only like 15 or 20 feet above the ground, and when we would have expected it to be a little bit higher, here we'd expect it to be a little bit lower, Here we'd expect it to be a little bit higher. So what are those situations that do that? We can analyze wind. We can analyze all sorts of different ideas at that point. So all this does is gives us more information to make good decisions based off of that. But the regression process is you always dump the values into the calculator, your coordinates, x and y. And then you set up your axes, you plot that in there, and then you go in there and you hit menu, and then you go to analyze, and then you go down to regression, and you are good to go. So that's the meat and potatoes behind it. Like I said, sometimes the regression gets you something that's spot on, sometimes it doesn't, and our job is to look at that and critically think about why our data is either really agreeing with it or why our data is not agreeing with it whatsoever. And that's our job. Our job isn't necessarily to find the regression. Our job is to understand what the heck is going on after we find the regression line, or in this case, the regression parabola. More examples in class. You got any questions? Take a look. Do a Google search for regression. All sorts of different resources out there. So have a great day. Hopefully this made sense to you. And if it didn't, the door is always open. Have a great day.